Okay, welcome to video class number 19. In this class, we are going to do some problems using Isar transform direct equation just to derive some Isar transform of some standard signals, as well as to get familiarized with the basic equation. Okay, now as you all know, we have studied in the last video, that is the basic expression of that is x of z is equal to sigma n is equal to minus infinity to plus infinity x of n z raised to minus n. So it is in this expression we will be focusing in this session. Okay, making use of this expression to find out the Z transform. Now the first question is to find out the Z transform of this signal. Okay, so this is a signal that is sine omega 0 n into u of n. So you can just make use of this expression. Simply x of z is equal to sigma n is equal to 0 to infinity. Why it became n is equal to 0 to infinity? Because that signal gets multiplied by u of n. So you know that in u of n you have only signals ranging from 0 to infinity. So that means all the negative half becomes 0. So you are using only n is equal to 0 to infinity. Now from this, if you can expand, you cannot write like this. So sine 0 into z raised to minus 0 plus sine omega 0 into z raised to minus 1 and so on. Now you cannot expand this. If you can express this sine omega 0 in terms of some exponential signal, you know, by applying Euler's identity, you can write sine omega 0 n as e raised to plus j omega 0 n minus e raised to minus j omega 0 n by 2j. This we got from the Euler's identity, right? Now from that you will be able to get an equation. Substituting that equation in the next step, you will get an expression like this. Okay, sigma e raised to j omega n by 2j minus, so you are taking this 1 by 2j, and okay, now you are splitting this, it's not splitting, you are dividing that summation to these two terms, or you are giving the summation to these two terms. So you will be getting two terms. One is e raised to j omega 0 n into z raised to minus n. Another one is e raised to minus j omega 0 n into z raised to minus n. Now what you can do is you can so this can be written as, so you can take this n outside from the powers of these two exponential signals. So e raised to j omega 0 into z raised to minus 1 the whole raised to n. This becomes e raised to minus j omega 0 into z raised to minus n. Do remember there is only one difference. Here you have e raised to j omega 0, then here you have e raised to minus j omega 0. Now just next step is to expand this summation. You know that you are simply putting it n is equal to 0, 1, 2, 3, etc. So substituting that, you will get 1 plus e raised to j omega 0 z raised to minus 1 plus e raised to j omega 0 z raised to minus 1 the whole square, etc. Here the difference is e raised to minus j omega. So you will be getting the same, almost similar series, but the difference is e raised to minus j omega 0. Now we have already seen that these two can be considered as a geometrical series of the form 1 plus r squared. So what is your common ratio? Common ratio is e raised to j omega 0 z raised to minus 1. Here the common ratio is e raised to minus j omega 0. So if you can impose a condition like this, like this, that is e raised to j omega 0 z raised to minus 1 less than 1 and e raised to minus j omega 0 into z raised to minus 1 is less than 1, you can straight away write the equation using 1 by 1 minus r, where r is the common ratio. So here the common ratio is 1 by e raised to j omega 0 into z raised to minus 1. This is 1 by 1 minus e raised to minus j omega 0 z raised to minus 1. Okay, now this you can do only by imposing these two conditions. Now let us work out with these conditions. What is actually the meaning of these conditions? So first of all, say look at this, modulus of e raised to j omega 0 z raised to minus 1 less than 1, meaning e raised to j omega 0 by modulus z is less than 1. When you bring this here, you can see that mod z is greater than modulus of e raised to j omega 0. What is the meaning of that? Modulus of e raised to j omega 0. Modulus of e raised to j omega 0 is nothing but it is cos omega 0 plus j sin omega 0. What is the magnitude of that? That will be root of cos square omega 0 plus sin square omega 0, which is equal to 1. So mod z is greater than 1. The meaning of this is mod z is greater than 1. What about this? This is also e raised to minus j omega. The only difference between these two is one is plus and other one is minus. There is no difference in the magnitude if it becomes plus or minus, because this is also going to be cos omega 0 minus j sin omega 0. When you take the magnitude, that also will be equal to, so you will be getting mod z. By evaluating, you will be getting e raised to minus j. So whether it is e raised to minus j omega 0 or plus j omega 0, the magnitude always remains as 1. That means the ROC for this signal, that is for sin omega 0 and u of n, to have this z transform, the ROC is mod z has to be greater than 1. Now how will you represent that? You will be representing that in an z plane. You will draw a circle with unit radius, and it is the region exterior. Now as we have seen in the last session, what is the now the ROC is exterior to a circle, means that particular signal is going to be causal signal. Okay, any causal signals will be having an ROC exterior to a particular region. Now in this problem you can see that this is exterior to the region. That means this particular signal is a causal signal. Obviously it is causal because it is multiplied by a causal signal to make it causal. So therefore this one is a causal signal, right? Now what about this? Now what you can do is you can take the LCM. Okay, and this problem we have a similar problem we have done when we studied about Laplace transform. So I'm not going to do it for you. Anyway, the method is just to find out the LCM, and you can make use of that Euler's identity in the numerator as well as the denominator to get an expression like this: sin omega 0 into z raised to minus 1 divided by 1 minus 2 cos omega 0 z raised to minus 1 plus z raised to minus 2. And what is its ROC? We have already found out to be mod z greater than 1. Okay, now let's move on to the second problem. Say the second problem is given by find the z transform of 2 by 3 raised to n into u of n plus minus half raised to n into u of n. So this is your x of n. Okay, now you are supposed to find out your x of z. Okay, now as per the linearity property which we have studied for some for other transforms, the linearity property which we will be dealing later as well for the z transform is applicable here also. That means if you can derive, or if you know this z transform intuitively, you can take the sum of this. That's it. So you will be getting your x of z. That is what I meant to say is x of z is x1 of z plus x2 of z. What is x2 of z? So this is actually the z transform of 2 by 3 the whole raised to n into u of n, okay, plus the z transform of minus half raised to n into u of n. Okay, now before going on to that, let's again look at the question. That is, this question is actually a combination of two causal sequences. That means the resulting x of n is also going to be causal. That means it will be having only values for positive values of time. That is, it only have this is defined only for the values 0, 1, 2, 3, etc. On the negative time, that is for minus 1, minus 2, etc., this particular signal is 0 because the two components got multiplied by u of n. So when you find out the x of z, what must be its ROC? ROC, you must have an idea about the ROC, or about the region of convergence. Okay, now we have already seen in our previous video that for a general causal signal, it will be always an exterior to a circle, and the only thing is that we do not know presently, we do not know the radius of that circle. That we will be finding out as we do the problem, but anyway we will have a picture of that ROC. That means that's going to be a circle, okay, a circle with the exterior region. Now we just need to know only the radius. What must be the radius of that circle, and the region is going to be the exterior of that circle with the particular radius. Okay, now let's start. How to find out this 2 by 3 u raised to n? So you can straight away use the basic expression x of z is equal to what? Sigma n is equal to 0 to infinity, meaning it is only causal. That's why we use 0 to infinity 2 by 3 n into u of n, plus sigma n is equal to 0 to infinity minus half raised to n into u of n into this into z raised to minus n, this into z raised to minus n. Okay, now let us try to expand this. What happens when n is equal to 0? When you put n is equal to 0, this becomes 1 plus 2 by 3 z raised to minus 1 plus 2 by 3 square z raised to minus 2, okay, etc. plus, now when you expand this summation, you will be getting this as minus half. So the first value will be 1, right? It is n is equal to 0, 1 plus minus half raised to 1 into z raised to minus 1, right? Then plus minus half raised to 2 into z raised to minus 2, etc. So you are actually getting two geometric series. This is one geometric series, this is another geometric series, with the common ratio is 2 by 3 z raised to minus 1 for this GP, while this is the common ratio is minus half into z raised to minus 1 is the common ratio for this. Okay, now you have a two GPs, the sum of two GPs, which is having two different common ratios. Now these two GPs will be converging if you can set a condition that this R should be less than 1. So let us try for this first GP. First GP to converge, what must be this condition? R has to be, modulus R has to be less than 1, or modulus 2 by 3 z raised to minus 1 has to be less than 1. Now when you make that, when you set this condition, as we know that the sum converges to, what is that sum? Sum converges to 1 by 1 minus R. So applying that, you will be getting, or you can convert this geometric series into the sum as 1 by 1 minus 2 by 3 z raised to minus 1, right? Then plus, what about this? This is also, okay, this is also, if you can put half z raised to minus 1 less than 1, this also this geometric series also converges to 1 by then the common ratio is minus half z raised to minus 1, so that becomes plus half into z raised to minus 1. Okay, now you can have a manipulation of that. Okay, so this will be you can say this as 1 by 1 minus 2 by 3 is z, okay, 2 by 3 is z, and plus 1 by 1 plus 1 by 2 is z, right? This is how it goes. Now when you can have the LCM and so on, LCM, and take the LCM, and no, you don't require that LCM. You can convert this into, say, z minus 2 by 3 by z, or you can say like this, say, you can prove this as z by z minus 2 by 3. How will you do this? Take this LCM, so this becomes 3z minus 2, okay, 3z minus 2, in the denominator you will be getting 3z, then you may take 3 outside, so that 3 and 3 cancel. So you may just do it by yourself. Okay, similarly you can prove this part as z by z plus half. Okay, so this is it. So you got this as the z transform of this. But the problem is not complete unless and until you should find out a common ROC for this. Individually the ROC is, no, let's start from where we have stopped. That is, you have found out one ROC to be 2 by 3 z raised to minus 1 less than 1. Let us see what it is. 2 by 3 modulus 2 by 3 z raised to minus 1, or 2 by 3 z raised to minus 1 is less than 1. What is the meaning of that? That is 3z is less than 1. Modulus 3z is less than 1. Or bringing this z, you can write like this: mod z is greater than 2 by 3. Right? Now what about this case? So bringing this, what is magnitude of minus half? It is plus half itself. So you can write this as half into, you can bring this z down, z is less than 1 or less than 1, or mod z is greater than half. Okay, now let's see. So this particular signal will be having this is a transform when mod z is greater than 2 by 3, right? While this particular signal will be having an z transform of this only in the region mod z greater than half. So among this, which is greater is obviously 2 by 3. So you can draw the graph like this. Okay, so you can have a okay, assume that this is a circle, then you can have another big circle like this. Okay, now so this must be half, this must be half, and this must be what? 2 by 3. So you have two circles with the radius 2 by 3 and plus half. Now what does this ROC suggest? For one case it is mod z greater than 2 by 3, that is the exterior portion of this, right? That means this particular signal will be having only the z transform, that is this particular signal will be having only the z transform only after z is greater than 2 by 3. That's the meaning. So it is exterior to the circle with radius 2 by 3. Now what about this part? This part says that this has got z transform only greater than half, that is from this region onwards. So when you combine this, what must be the ROC? ROC, obviously, when you think logically, you can see that it has to be the intersection region. So what must be the intersection region or the common region of both? The common region of both has to be greater than 2 by 3. So what must be its ROC? Its ROC is mod z greater than 2 by 3. Now how will you represent that? So you should represent by this diagram as well. The ROC has to be drawn for every problem. Okay, so this is, mark this as 2 by 3 and shade the exterior region. Okay, now what type of signal it is? It is a causal signal, which we have already studied. For a causal signal, the ROC will be exterior to the circle. Now after doing the problem, we found out the radius of that circle to be 2 by 3. Okay, hope you understood this. Okay, now next problem is find the z transform of x of n a raised to modulus n. Now we have already seen in discrete time signal that a raised to n is actually denotes the exponential discrete time signal, right? Now since, and there is a condition imposed or condition given in the question, that is a is less than 1, and this n will take only the positive values, or it will take all the negative values, or irrespective of whether it is negative or positive, this will be taking only the magnitude part. That's the meaning. So as long as this part is positive and a is given to be less than 1, this signal x of n converges in both the direction, that is in the positive direction of n as well as in the negative direction. And if you just try to draw the signal, so the first so at n is equal to 0, this will be having a value 1. From that onwards it will reduce exponentially like this, right? So that's what I said, on both sides it will converge to 0. So therefore this particular signal converges. And now how will you find out the is a transform of this? So as usual, you can use this the double-sided sequence. Why double-sided? Because the signal is a double-sided. So this is n is equal to minus infinity to plus infinity, a raised to modulus n into z raised to minus n. Okay, now before going into that, what type of signal it is? This is a double-sided signal. Now we have already studied that for a double-sided signal the ROC has to be a circular strip, or it we call as the annular ring. Now let us try to see that whether its ROC, the ROC of this particular problem, is going to be an annular ring or exterior or interior. Anyway, from our study this has to be an annular ring. Okay, now let's try to do this problem. Now you can have a split of this summation as n is equal to minus infinity to minus 1, that is a raised to modulus n z raised to minus n, plus sigma n is equal to 0 to infinity a raised to modulus n z raised to minus n. Okay, now you can just take the you can just change the polarity of this. That means you can reverse the limit, reversing the limit, meaning n is equal to 1 to infinity. The only thing that you need to do is you put n, instead of n you put minus n. So when you put a my modulus of minus n, it still remains a raised to n, right? And here when you put z minus n, so z raised to n. Okay, hope you understood this, why this negative becomes positive, because you are changing the limit. These are the negative limits, you are changing it to positive, so that obviously this has to change, and the magnitude won't change because it is already modulus n. Plus then this is sigma n is equal to 0 to infinity a raised to n into z raised to minus n. Okay, now let's try to expand this. When you try to expand this, what is the first term? This is n is equal to 1. So the first term is a into z plus a z square, right? A z square plus a z cube, etc. Plus, then what about this? This will be 1 plus, the first term will be 1 plus a z raised to minus 1 plus a square z raised to minus 2, etc. Okay, so you can see that you can okay, in the next step, this is a geometric series of the form 1 plus r square, etc. But this is not of the form 1 plus r square. Then only you can apply that convergence equation. So in order to make it of the form 1 plus, we just take one a z outside. So this becomes 1 plus a z the whole square, a z plus a z the whole square, etc. Okay, now plus 1 plus a z inverse plus a square z raised to minus 2, etc. So that means you have a two geometric series, sum of two geometric series. Okay, sum of two geometric series with the common ratio. Here the common ratio is a into z, while here the common ratio is a into z raised to minus 1. Okay, now if you can assume this a z is less than 1, as I told you earlier, the sum can be converged to a sum of 1 by 1 minus r, where r is the common ratio. Now if a is less than 1, you can write the sum to be, that is this part becomes a z, there is an a z here, a z into 1 by 1 minus a z, right? Okay, 1 by 1 minus a z. Now similarly this part, this is a z inverse. So if you can assume a z minus 1, modulus of this is less than 1, you can convert this sum also as 1 by 1 minus a z minus 1, right? So now how will you do this? Now you can have a simple manipulation of this. You can take this a outside, so this a and a gets cancelled. So therefore this term becomes 1 by a minus z. Okay, I'm using the same shape of z. So z by 1 minus a, then 1 by, so this will be z by, so when you bring this down and taking the LCM, you will get this as z by z minus a. Now to make this term similar to this, you can take a negative sign and you can write this expression as so this will be z by z minus a minus, this is minus z by z minus 1 by a. Okay, now the next question is, what is the effective ROC of this? We have already found out the ROC to be here. The ROC is to be AZ less than. So what must be the ROC here? ROC is less than 1 by A. What about this? This is magnitude A by Z is less than 1 or mod Z is greater than A. Right, mod Z is greater than A. So we have found out that for this case, for this case it is mod Z greater than A, mod Z less than 1 by A. So again we are going to draw a circle. Okay, we know that A is less than 1, a condition is imposed. So which is greater, 1 by A or A? Obviously 1 by A has to be greater. So you are going to draw a circle, a small circle with radius A. Okay, then we'll be drawing another big circle with radius 1 by A. So this will be a circle with radius 1 by A. Okay, so you are marking this as 1 by A and this one as A. Okay, so what is the inference? One is, so this part, that is for this signal, this is this part, right? You have divided the signal. Now it has got two parts. One is mod Z is less than 1 by A, other one is mod Z is greater than A. So in order to have these both the side, these are two sides. One is the non-causal part, the other one is the causal part. For the non-causal to have, this is the non-causal part, right? For the non-causal to have this Z transform, this is actually the Z transform. So you can call this as plus of minus, right? So this is the Z transform of this non-causal part, while the causal part is the transform of this. Now in order to have this combined Z transform, what you need to, so for example, for this non-causal part, the Z transform, for the presence of Z transform, mod Z has to be less than 1 by A. Obviously for a non-causal signal it will be always less than so one is, it is less than 1 by A, meaning this is the region, right? Inside, well inside. Okay, well inside the circle, so the whole circle. Now there is a restriction imposed by this particular causal signal. Why? This is the causal part. Now what is the causal parts Z transform? This is the Z transform. For the combined Z transform to exist, this must also be taken into consideration. That is, mod Z has to be greater than A. That means it has to be greater. So which is the intersection region? That is the region that lies in between A and 1 by A. Now it can't be less than A. What happens at less than A? Less than A, this non-causal will not be having an Z transform. So for these two parts to have the Z transform simultaneously, this must be the intersection region between 1 by A and A. So this is the circular strip formed by the shaded region. Okay, so it again verifies our conclusion that for a double-sided sequence, the ROC has to be an annular ring or a circular strip. Okay, and this when you okay, now let's move on to the next problem, which is x of n equals half raised to n into u of minus n. What is the speciality of this signal? This is multiplied by u of minus n. U of minus n is like this, right? So when you multiply any signal by such signals, it will become a non-causal signal. Now if this is a non-causal signal, what is going to be the ROC of the Z transform? This is, which we have already seen, that must be interior to a circular region, right? Interior to a circular region. Now the only thing that we need to know is the radius of that circle. Okay, that we will be finding out when we find out the Z transform. Now what is the Z transform? Z transform is sigma n is equal to minus infinity to 0. Only you will be considering the negative aspect, negative time. Half raised to n into u of minus n will be 1. It will be into Z raised to minus n, right? Now, so you will be having this as sigma n is equal to minus infinity to, okay, you are going to expand this, right? Now once you expand from 0 to infinity, the first term will be 1, second term will be half raised to minus 1, 0 to minus 1 minus 2. Okay, so this is minus 1 z raised to 1 plus half raised to minus 2 z square, etc. Now this is a geometric series, right? Now if you can impose a condition that half raised to minus 1 z is less than 1, or in other words, what is half inverse? Half of raised to minus 1 is, it is nothing but 2z is less than 1. Mod instead of 2z is less than 1, you can write this expression as 1 minus, okay, 1 minus half inverse, which can be written as 2, right? Half, this is your so 1 minus r. 1 minus r is half inverse. Half inverse is 2. Half raised to minus 1 is 2. Then into z. So this is 1 by 1 minus 2z. And what is the ROC here? ROC here will be less than 1 by 2. Okay. Now this must be a circle with radius half, and what is the region? Region will be less than this region. So the whole interior portion of a circle. Now what is this signal? This signal is a non-causal signal, and for a non-causal signal the ROC has to be the interior of a circle. So in this problem the circular radius is half, so it is less than half. Okay. So we have done some problems. Similar type of problems and some standard signals, it's given in the textbook, and you may do it as an exercise. And not only that, there are some more standards Z transform pairs. You can see that in almost every textbooks of signals and systems, and just go through that table and try to do some problems. Say, I'll give you some samples of that. You may just go through that. Say you may just try to of course you have dealt with this type of signal already, a raised to, you know how to find out this. Say just do it by yourself again. Now find out del of n minus m. Okay, find out the Z transform of these signals, and try to find out n into a raised to n into u of n by using this basic expressions. Okay, now we have already seen something about cos sin omega 0 n. So similarly you can try cos omega 0 n into u of n, and okay, so you may just go through this textbook and find out that especially the table containing this is a transform pairs, just as we memorize, or just as we need the table of Laplace transform standard signals, we also require the knowledge about some Z transform of some standard signals in order to find out the, especially it is needed when you study inverse Z transform. Okay, now the next one is properties of Z transform. So as always, I used to explain what is the need of these properties. Properties are said to be the shortcut to do problems. Sometimes if you are aware of the properties, you may not require the, so far we have studied, we have done some problems using the direct evaluation of, using the direct expression of Z transform. But if sometimes if we may be knowing the properties, we may not need the help of that direct evaluation of Z transform. If you know the property, you can straight away arrive at the solution without going for the high calculations. Okay, so properties can be considered as a shortcut to arrive at the results. So number one is the linearity property. Now linearity property, so you may be very much aware of this, very much familiar with this, because in almost all the almost all the transforms and series we have seen this property, the linearity property. Again, I'm just specifying. Say suppose you have two signals, x1 of n and x2 of n, whose Z transform is known. That is, Z transform pair is represented like this. Say let it be x1 of z and the Z transform of x2 of n be x2 of z. Now what will be the, if that is the case, what is the Z transform of a into x1 of n plus b into x2 of n? Okay, so you can simply use that expression to prove it. Now the proof is, you're going to prove it. Now to prove that it is n is equal to minus infinity to plus infinity, a into x1 of n plus b into x2 of n into z raised to minus n. Okay, this is the basic expression. Now so that this becomes equal to, you can n is equal to minus infinity into a x1 of n into z raised to minus n, and you can give the summation to each terms like this, b into x2 of n into z raised to minus n, or this is nothing but a times, you can take the a outside, so that this becomes x1 of n into z raised to minus n. What is that? That is a Z transform of x1 of n. We have assumed that Z transform to be x1 of z, while plus taking b outside, the rest is going to be the Z transform of x2 of n, which we have already assumed to be x2 of z. Okay, so this is a times x1 of z plus b times x2 of z. That is the Z transform of this. Now the question is, what's going to be its ROC? ROC is the ROC of the intersection. ROC will be the intersection of the ROCs of x1 of z and x2 of z. Okay, fine. Okay, just look at the problem that we have done earlier, that is 2 by 3 n u of n plus minus 1 by. Okay, so this is the direct way of evaluating this. Now suppose this is actually a standard form of the form a raised to n into u of n. Now if you know the Z transform of a raised to n into u of n, you can simply write that as z by z minus a. So instead of a, it will be 2 by 3. In this case it will be minus half. Now if you know already this standard result, that is standard result, you don't have to go through this method. Now applying the linearity property, you can take the sum of the Z transform of this plus the sum the Z transform of this. Okay, now what is the ROC of this combined signal? That's going to be the intersection. That's what we have explained previously. Okay, so it will be, so in this case it can be mod z greater than half as well as mod z greater than 2 by 3, but we know that mod z greater than 2 by 3 will only, this combined signal will have a common region of convergence. Okay, so that's why it is told that the ROC is going to be ROC of in a linearity property, the ROC of the resulting signal will be the intersection of the ROCs of the individual Z transform. Okay, next is the time shifting property. Okay, time shifting property. Now what is this time shifting property? So that is, say you have x of n whose Z transform is x of z, then x of n minus m will be z raised to minus m into x of z. So you just need to prove is Z transform of x of n minus m will be equal to sigma n is equal to minus infinity to plus infinity x of n minus m z raised to minus n, right? Now put n minus m is equal to p, so that n becomes equal to p plus m. So n varies from minus infinity to plus infinity, that means p also varies from minus infinity. Substituting that, you will get p is equal to minus infinity to plus infinity x of p into z raised to minus of n. Instead of n, you can write this as p plus m. Okay, so this is sigma p is equal to minus infinity to plus infinity x of p into z raised to minus p into z raised to minus m. So what is this? This is actually equal to instead of n you have p, so you can call this as your x of z into z raised to minus m. Now what can you say about the ROC of this signal? This is also important. Now what do you call as the ROC? See, suppose here anyway, let's call this ROC as R1 of x of z. So the x of n minus m is a transform. The z transform of x of n minus m is having an x of z. That means it will be having an ROC of x of z itself. So you can say that ROC of x of z. What is that? We have assumed to be R1. So this is R1, but you should exempt a point. What is this? X of z. So this can be written as x of z by z raised to m. So when this becomes when this particular z transform will not be having a meaning when it becomes infinity. Now it becomes infinity only at z is equal to 0. So you need to specify that it is the ROC, it is R1. The ROC will be R1 except what? Except z is equal to 0. Because at z is equal to 0, because of this term, this can go up to infinity. So in order to exclude that, you should exclude this point that z is equal to 0. Okay, now next is a special case of time shifting property. Now in the special case, before that I am going to explain a notation called as x plus of z. What is this x plus of z? We have seen the same thing in a Laplace transform called as a unilateral Laplace transform. So if it considers only the causal sequence, that is if the x of z is only, if it is considering only the positively defined time domain signals, that means obviously the n becomes from 0 to n varies from 0 to infinity. So this is actually called as a unilateral z transform. Okay, this is unilateral z transform, or it is also called as x. It is designated as x plus of z. Now you can have a time shifting property, that is, say for example, if say you have x of n minus m. So in this case, your assumption is x of n is z transform is x of z. So x of n minus m will be z raised to minus m into x of z. That's a general case. Now you have a special case of this. If it is a causal signal, then it will be having one more term apart from z raised to minus m into x of z. So that will be z raised to minus m into x of z plus z raised to minus m into sigma k is equal to 1 to m x of minus small x. Do not, it is small m, small x of minus k into z raised to k. Okay, so what does the small x represent? Small x is actually the time domain signal. Okay, so you are putting some values from, and k varies from 1 to, yes, it starts from 1 to how much? 1 to the total shift. Say for example, I'll just give you an example of this. Say for example, if you are to find out x of n minus 2, that is, you have a time domain signal x of n. It is shifted by 2 units. Okay, then what is a z transform? Normally while we do problems, we simply take this as what is going to be z transform. It will be as per this time shifting property, we simply write this as z raised to minus 2 into x of z. Okay, that's right. Now when you consider an unilateral z transform, as the special case will be, So under the special case, this will be x of n minus 2 will be equal to, it is not only z raised to minus 2 into x of z plus you will be having an z raised to minus 2 into what? Sigma k is equal to 1 to how much? M is 2. 1 to 2 small x of minus k into z raised to k. So you can expand that as, so the equation will be, so the final answer will be like this. This will be plus, okay, what is the first term? X of minus 1 into z raised to, so this is small x of minus 1 into z raised to 1 into z raised to minus 2 plus x of minus 2 into z raised to 2 into z raised to minus 2. So this and this get cancelled, so this will be minus 1, okay, this will be minus 1. So these are the, so what is this? These are all this represents the time domain signal, the value of time domain signal at n is equal to minus 1 and n is equal to minus 2. Now can you make a guess where it will be used? It will not be used where during, I mean, the normal problems. While we do the normal problems, we will be using only this time shifting property. This will be used, or this finds its application when we come across with the analysis of a system using its transform. Now in the analysis of a system, we require something called as the initial condition. So x of minus 1, x of minus 2 always refers to the initial value or the initial state of the system. So in that case, we may be using this special case of time shifting. So anyway, you should have you should study this, because you will need when you do the system analysis using Z transform. Similarly is the case, instead of, if it would have been x of n plus m, then the if it would have been x of n plus m, so you may have a note of this. Say suppose if it is x of n plus m, then this will be equal to z raised to m into x plus of z minus sigma k is equal to 0 to, it is not m minus 1 small x of k into z raised to minus k. Small x of k, it is not minus k, it is small x of k into z raised to minus k. Okay, so you may have a note on these two items. These are special cases. Okay, these are special cases, that is we will be using this only during the time where we use the Z transform for system analysis, and during that time we need to consider the initial conditions and so on. Okay, fine. Now next property is, say you have x of n is Z transform is x of z, then it is a raised to n into x of n. If this x of n, what is a raised to n? A raised to n is the discrete time exponential signal. Okay, so if it is multiplied by an exponential signal, what is the Z transform? So if it is multiplied by a raised to n, then the answer you will be getting is a inverse of z, or this is same as x of z by a. What is the meaning of that? A inverse of z is z by a, or it is called as the frequency scaling. You can say that in that way. So it gets scaled. So this will be x of z by a. Now we are going to prove that. So in order to prove that, we just find out the Z transform of a raised to n into x of n, which is nothing but sigma n is equal to minus infinity to plus infinity a raised to n into x of n into z raised to minus n, right? Now you can combine these two terms which are having the powers of n. So this can be rewritten as minus infinity to plus infinity x of n into, okay, a into z raised to, so a raised to n into z raised to minus n. Now the same expression can be written as n is equal to minus infinity to plus infinity x of n into, okay, we need a power raised to minus 1. Now we want to convert it into an Z transform equation. So x of n into something raised to minus 1. This something raised to minus 1, minus n, sorry, something raised to minus n. If it wants to be like that, then it has to be A inverse into Z, right? Now let us look at the expression of the Z transform. What is the expression of x of z? X of z is nothing but sigma n is equal to minus infinity to plus infinity x of n z raised to minus n. That means when you talk about this function is the variable whose power is raised to minus n. Am I right? Now if you write this as a function similar to that, this is going to be a function of the variable raised to minus n. What is that variable? It will be A inverse z, right? Okay, so or it is equal to x of z by A, right? Now suppose now we haven't talked anything about the ROC. Suppose let the ROC be say let the ROC lies in between R1. We are not sure whether this signal is a causal or a non-causal. It can be a general signal, so you can make use of this, no, mod z less than R2. So this is a general ROC. That means if it is a causal signal, this will be mod z greater than R1. If it is a non-causal signal, it will be less than R2. If it is a double-sided signal, that has to be between R1 and R2. So you can consider this as a general ROC of this equation. So instead of z, you have A inverse of z. That means you are going to write A inverse of z is less in between, it comes in between R1 and R2. Okay, so this is z by A, or this is z by A. That means mod z will be equal to A R1 less than A R2, right? So this is how ROC looks like. Okay, now if it is a causal signal, then it will be only having mod z greater than A times R1, right? If it is a non-causal signal, it will be having only mod z less than A R2. If it is a double-sided signal, then this will be A times R1 in between, or the region lies in between A R1 and A R2. Okay. Okay, now we have already seen three properties, and among this linearity property I have used a previous example which we have done to illustrate this linearity property. Now to illustrate this time shifting property and multiplication by exponential sequence, let's do two different problems to illustrate that, or to study how to apply a time shifting property. See, okay, let's start with a simple u of n minus 1. Okay, the Z trans of u of n minus 1. Suppose if you are not aware of this property called as time shifting property, you can do it only by using this sigma n is equal to, say, of course n is equal to 0 to infinity u of n minus 1 into z raised to minus n. What is this u of n minus 1? N minus 1 is this one, right? This is u of n minus 1. 0, 1, 2, 3. This is 1, 1, and at the 0th sample you have no value. So that when you expand this, what you are going to get is this is 0 into z raised to minus 0. So this is equal to 0 plus next one is 1 into, so you will be getting this as z raised to minus 1. When you expand this, u of n minus 1 will be 1. So this is 1 into z raised to minus 1 into 1 into z raised to minus 2 into 1 into z raised to minus 3, etc. Right? Now this is a geometric series. Now if you can set a condition like this, minus z raised to minus 1 is less than 1, you can say that okay. Now before doing that, just see that is it a geometric series of the form 1 plus r plus So in order to convert that to of that form, you just take z raised to minus 1 outside, so that this becomes z raised to minus 1 plus z raised to minus 2, etc. Right, now this condition, so this is of the form 1 plus r square plus etc. Right, so your r is modulus z raised to minus 1. If you can set such a condition, you can write this expression as z raised to minus 1 into what, 1 by 1 minus z raised to minus 1. Okay, so this is nothing but z raised to minus 1 into 1 by 1 minus 1 by z, or this will be z raised to minus 1 into z by z minus 1, or what is z raised to minus 1 into z? So you will get, this 2 gets cancelled, so that means this becomes 1 by z minus 1. Okay, fine. So what is the z transform of u of n minus 1? Z transform of u of n minus 1 is nothing but it is 1 by z minus 1. So this is a standard result, you need to remember this by heart. Okay, u of n minus 1 is 1 by z minus 1. Okay, now how to apply? Suppose the question would have been, find the z transform of u of n minus 1 by using time shifting property. Now what is the time shifting property, which we know? Now the time shifting property states that if you have x of n was z transform is x of z. Now what is the x of n corresponding to u of n minus 1, or what is the basic signal? The basic signal is u of n. Okay, now u of n, we know that its z transform will be z by z minus 1, which we have already derived in the previous slide. Okay, in the video number 18. Okay, now we have also found out its ROC to be mod z greater than 1, right? Okay, now what about u of n minus 1? U of n minus 1, therefore the z transform of u of n minus 1 will be what? As per this expression, if it is n minus m, it will be z raised to minus m into x of z. Instead of m, you have here z raised to minus 1 into z by z minus 1. Okay, z by z minus 1. What is that? When you get this, you will get this as 1 by z minus 1. And what is its ROC? ROC will be mod z greater than 1, except at z is equal to 0, right? Because of this term 1 by z. But you don't have to mention that, because if the ROC is mod z greater than 1, that also excludes what? Excludes the point z is equal to 0. So you don't have to mention that. So the ROC is exactly the same as that of u of n. Okay, so that's how you need to apply this time shifting property. Now similarly, say find the z transform of the signal given by x of n is equal to half raised to n into u of n, and verify using multiplication by exponential sequence property. So verify that your answer by this using property. So first of all, as you all know, if you are not aware of the property, what you just need to do is you can just find out its x of z as what? X of z as sigma n is equal to 0 to infinity half raised to n into z raised to minus n. Now this term will be half into z raised to minus 1 plus half square in z raised to minus 2, etc. Right? Now if you can set a condition that half raised to z raised to minus 1 is less than 1, magnitude is less than 1, you can straight away write this expression as 1 by 1 minus half into z raised to minus 1, right? So what will be this? So this will be 1 by 1 minus 1 by 2z, right? So this is equal to 2z by, so this will be equal to 2z by 2z minus 1, or in other words, if you take 2 outside, you can write this as z by z minus half. Okay, so this is actually your z transform of what? Half raised to n into u of n. Okay, so this must be right because this we have derived from the direct expression. Now what must be its ROC? Its ROC is 1 by 2 z is less than 1, or when you bring this z here, z is greater than half. Okay, right. Now how to apply this property? This property is x of n. If you have, what is the basic expression? You are multiplying this with the half raised to n. So your basic expression is u of n. So you know the z transform of u of n to be, what is that? Z by z minus 1. Z by z minus 1 mod z is greater than 1, right? It is mod z greater than 1. Then, so what will be your, what is half raised to n into u of n? Half raised to n into u of n will be you just need to substitute what? A inverse of z. So here in this problem, this will be x of half raised to minus 1, which is 2, right? 2z. Substitute x of z. So this is your x of z. In x of z, you just substitute 2z. So doing that, that is substitute. So what will be your x of 2z? If this is your x of z, x of 2z will be 2z by 2z minus 1. Taking 2 outside, you will get this as z by z minus half, right? Now instead of this, you have this as mod z greater than 1. Z has to be replaced by what? 2z, right? 2z, modulus 2z is greater than 1, or modulus z is greater than half. Okay, you're getting exactly the same answer, right? So this is the power of this property. If you know the property and some basic standard results, you don't have to go through this go through these steps to arrive at the expression. If you know the basic z transform, and you can simply apply the properties if you are very much aware of that. So that's the power, and that's the speciality of properties of any transforms. Okay, now number 4, property number 4. So let's see, time reversal property. What is this time reversal property? So if you have x of n whose z transform is x of z, then the solution of x of minus n, or the z transform of x of minus n, is said to be, and that's nothing but it is, instead of x of z or z in x of z, you just replace that by z raised to minus 1. Now let us try to find out the proof. The proof of this is, so try to find out the z transform of x of minus n. So this is your proof. You need to study the proof of each and every properties, because this is very important. Usually these questions can be directly asked like that: state and prove any 5 properties or any 7 properties of is a transform. Okay, so it's a very important. You need to study and you should know how to prove it as well. So when you take the z transform, what is that? N is equal to minus infinity to plus infinity, x of minus m into z raised to minus n, right? Now you can say simply write, say some p is equal to minus n. So since p is equal to minus n, n also varies from minus infinity to, so p also varies from minus infinity to plus infinity. So this will be x of p into z raised to p, right? Okay, now you can rewrite, or you can have a rearrangement of this as sigma p is equal to minus infinity to plus infinity, x of p into, we need for the z transform expression, we need always a term like z raised to minus p. So in order to obtain that form, what you can do is you can put a minus 1 and a minus p, so that this becomes z raised to minus p. Now what is your x of z? As I mentioned earlier, what is x of z? X of z is is the expression like this. Now this is actually going to be the expression of what? Expression of the variable which is raised to minus p, or similar to x of n into z raised to minus 1 the whole raised to minus n. So this is going to be a function of what? This is going to be a function of x of z raised to minus 1. Okay, so this is it. Now what about the ROC of that? Say, what will be the ROC of that? Say, since it is a general expression, we are not aware of the ROC, so let us call this as modulus z r1 less than modulus less than r2. So this is the general expression. Now instead of z, what you do is, in this case you will do, say, r1 less than modulus of z raised to minus 1. Instead of z, you need to put it as z raised to minus 1, or r1 less than z raised to minus 1. That means 1 by z is less than r1 r2, or what's the meaning of that? When you put modulus z, that is, you are reciprocating this. When r2 is 1 by z is less than r2, or z is greater than 1 by r2, so that this becomes, this is 1 by r2 and 1 by r1. Hope you understood. When you take the reciprocal of it, the lesser value becomes greater and greater value becomes lesser. That's the logic. Okay, so this is your modulus. Now just let's have a look at an example to apply this property. Now, what is the Laplace z transform of u of minus n? Okay, you may just look at this. How to find out the z transform of u of minus n? Okay, now how to find that? So this is nothing but n is equal to minus infinity to minus 0 u of minus n, because u of minus n is having only values from minus infinity to 0 into z raised to minus n. So when you put n is equal to 0, this will be 1. Okay, 1 plus, then again you have a 1, but z raised to minus of minus 1, this becomes plus 1, z square, etc. So this will be 1 by 1 minus z, provided mod z has to be less than 1, right? Mod z less than 1, this is 1 by 1 minus z. Okay, so this is the expression of 1 by 1 minus z is the z transform of u of minus n. Now let us try to apply this time reversal property. So for time reversal property, you just need to know the z transform of u of n. What is that? The z transform of u of n is what? Z transform of u of n is z by z minus 1, right? Okay, now if you want to find out z transform of u of minus n, what you need to do is, instead of x of z, substitute z by z raised to minus 1. So in this example, if you substitute by z minus 1, this becomes z minus 1 minus 1. What is this? This will be 1 by z into 1 by z minus 1. Okay, so so this will be 1 by z into 1 minus 1 minus z by z. So this is z and z cancels, so this will be 1 by 1 minus z. Now this is x of z raised to minus 1. Okay, so you got the answer to be z transform of u of minus n. By applying the property, you got the answer to be 1 by 1 minus z, right? Okay, so this is the answer which we got directly from that expression. Now how to obtain this? Okay, now from this we will be starting this from this. Okay, what is the ROC of this? This is mod z is greater than 1. Now substituting z inverse, putting z inverse instead of greater than 1. So what will be that? This is z mod z is less than 1. Okay, so you're getting the same answer.